Hello. Am I clearly audible? Okay, then we can start our today's lecture on association rule mining. So we have started this discussion in our last class, and we can continue this discussion here. So in our last class, we have, we can start from this slide, finding frequent item set. Okay, finding frequent item set. If a data set is given, like here, this is data set. In this case, the transaction ID 100, 200, 300, and 400. And items, we can see 1, 3, and 4, 2, 3, and 5, 1, 2, 3, 5, and 2, 5. So these are the items given. Then we want to find out the frequent item set first. And then based on the frequent item set, we have to actually construct the rules. Okay, we have to derive the rules. Now, so at first, what we have to do, we have to think about finding out the candidate sets. Okay? So at first, the candidate set. So here, candidate sets, we can see there is what are the items. So in this case, we can see that the items are here is 1, and then 2, and then 3, and 4, and 5. So these are the 5 individual items. So these are the items. Okay. Now in candidate set, so at first we need to think about each and every item. Like here, item number 1. How many times item number 1 appeared in the data set? So we can see item number 1. Here is also item number 1. We can see 2 times. Okay. So that's why it is mentioned the item set and the count of that. And then next, item number 2. We have another item number 2. 1 time, 2 times, and 3 times. So here is item number 2, 3 times. In this way, we have to count like item number 3, 3 times, item number 4, 1 time, item number 5, 3 times. Okay, after finding out the candidate sets and there is the count or frequency, the next we have to find out the item set, that is frequent item set. So here frequent item set 1 means each and every item set just only consists of one item. Okay, so frequent item set of one items. The frequent item set of one item. So this time we have to filter the candidate items using our support, that is the support threshold. So mean support, it is mentioned that 50%, or you can say 5.5. So 0.5. So mean support is 0.5. That means minimum support it will equal 0.5. As we can see that we have counted those things, like this is the count. So we can determine the support for each and every one. Like for count 2, what will be the support? We know the support is, that is the count of that item, the frequency of that item divided by n. So here we can see for the 1, 2 times the 1 is appeared. So the support will be 2 by how many transactions are there? Here 4 transactions, that is 4. The support will be 2 by 4, that is 0.5. 0.5. Similarly, for another item, that is item number 2. Item number 2 appeared 3 times. Okay. So that means support will be 3 by 4. Okay, 3 by 4. That means 0.75. 0.75. So in this way, we can see here is just one time, 4 appeared just one time. The support is 1 by 4. That is 0.25. Okay, 0.25. So now, if we apply this filter, that is minimum support filter, so that means the item set which pass the minimum support threshold, we will keep those items only. So here 0.5, and we can see that this one, the support is uh, 0.5. So that means we have to keep this one. And the next one, 2, 3, the support is 0.75. So we have to keep that one. Here is the 3 times. That means it will be also 0.75. We have to keep that one. 4, the support is 0.25. So that means this is below the threshold of minimum support, 0.5. It is 0.25, but you can see here the threshold is 0.5. So we have to drop this one. And then 5 mentioned 3 times. So what we have to do, we have to keep it, because we can say 3 means 0.75. Okay, 0.75. That means we have to keep it. So these are called the item set of one item. Item set of one item. The next, what we have to do, next we have to calculate again the item set. Okay, that is candidate item set. Candidate item set of 2 items. Candidate item set of 2 items. So candidate item set of 2 items. And now what we have to do for this is called candidate generation. We will see the candidate generation algorithm. But here you can see that how to generate the candidates. We have in F1, we have 1, 2, 3, and 5. These items. That is 1, 2, then 3, and 5. These 4 items. You can see we have these 4 items now remaining. So for candidate item generation, what we have to do at this stage 1, we have to combine with or group with 2. Okay, so we can form a set 1, 2, then another set is 1, 3, then another set is 1, 5. So here is the 1, 2, 1, 3, and 1, 5. Then next set we can maybe build, that is by 2 and 3. So these 2 items, so 2 and 3. So here 2 and 3, we can make these 2 as one group, and again 2 and 5 is in another group, and then lastly 3 and 5 another group. Okay, so these are the possible set of 2 item sets from F1. Now again we have to count the frequency. Okay, the frequency or you can say support. So we have to count the frequency and the support as well. Okay, so here's 1, 2. So how many times 1, 2 appeared in our data set? 1, 2 appeared together. In this case, we can see this is the case. That is 1, 2 appeared just one time. And then 1, 3. So how many times 1, 3 appeared? Here is 1, 3. Here is also 1 and 3. So that means 2 times. Here is the 2 times. And 1, 5. We can see here 1, 5. 1, 5 is just one time. So in transaction number 300, we can see 1 and 5. So here is the 1, 5, just one time. And then next, 2, 3. Okay, 2, 3. Here is the 2, 3. How many times 2, 3 appeared? We can see 1, 2, 2 times. Okay, so 2 times. The 2, 5 2 5 3 times, and 3 5 3 5 2 times. Okay, 2 times. So if we got the frequency, then we can find out also the support. Okay, find out also the support. That means for one, just if we can say out of the four, how many times that subset appeared. Based on that, we can calculate the support. So for one, the support will be like 1 by 4. So 1 by 4 is 0.25. And for 2, we will get the support is 0.5. And for 3, we will get the support 0.75. We have already seen this one here. So that means we have to filter out to form the frequent item set of 2 items. So frequent item set of 2 items. In this case, we can see that this is there is 1. That means we have to drop because minimum support required support is 0.5, but it is below that. We have to keep this one because the support is 0.5. For this case, for this item set, the support is 0.25, so we have to drop that one. Now for this one, it is 2 3. It's 2. That means we have to keep this. It is 3. We have to keep this. It is 2. We have to keep this. That means this is our frequent item set of 2 items. Now the next is we have to again find out our candidate item set of 3 items. Okay, candidate item set of 3 items. And for that, what we have to do? This is a set and this is another set. We have to check all the sets. We have to check all the sets.
Sorry, it seems that there is no set for 1, 2,
Yeah,
and 5, or
yeah,
1, 3, and 5.
yeah. So that means we can see actually here it is started with 1. Okay, so that means none of the set starts with 1. So that means this set cannot combine with other set. Okay, so we have to, that means drop this one because this is actually it is not possible to combine this set with the other one. Now again, the next we can see here for this set, at first the 2 is there. So that means we have to find the same subset like 2, and here is the 2. Okay, so that means we can combine these two. So if we combine these two, then we will find like 2 3 and 5. So 2 3 and 5 will form a set. Here the 2 3 5 form a set. And then you can see that it here is the 3. Okay, so that means 3, there is no other set start with just 3. We can see that this set will not actually make any pair.
So the ordering matters.
Yeah, order is matter.
Okay.
So next, the C3. So this means candidate set of 3 elements. Okay, 3 items. So this is the candidate. Now what we have to do, we have to count the frequency of this candidate and determine our support again. So in this case, 235, we can say 235, 235. This is 235 here, and here is also 235. So two times appeared. So that means 235 appeared 2 times. Then we have to again apply the filters. We can see minimum support is 0.5, and here is also the support of this set is 0.5. So that means it passed the threshold. So now we got this item set of 3 items. Okay, 2 3 5. We can again we can try to actually find this the candidate set of 4, but we can see that actually nothing will be there. Okay, because there is only one set we have, and it cannot be combined with some other sets. Okay, it will try but fail to do that. That means finally it will get f4 equal null. So if it gets like f4 equal null, then it will stop there. and then it will return the the frequent item sets. So frequent item sets of 3 items. This is the frequent item set of 3 items, and this is the frequent item set of 2 items, and also frequent item set of 1 item like this. So these are the frequent item sets in our data set. So here ordering, as I already mentioned, that the order is matter here. That means you can order your items using the lexicographic order. So lexicographic order, that means kind of dictionary or alphabetic order. Okay. So if we have the item set with the string values, then we have to think about like lexicographic orders. That is alphabetic order. But if we assign equivalent number, or you can say label encoding, then that is the each and every item will be different. Each and every item will be encoded to different numbers. Okay? And then you have to just order that one in ascending order. So here it is mentioned that there is okay, maybe we can say we have one subset of k item set, okay, subset of k item set, and this is the subset w1, w2, wk up to k item set. That means we can say k, if we can consider k equal 5, then in this item set there will be 5 elements. So on that item set, these will be our elements, okay? And where we have to maintain the order, there is W1 and then W2 up to WK according to lexicographic order. Okay, now the a priori algorithm for our frequent item set construction. So we have already used this algorithm. Now we can see how actually the algorithm is designed. So in this case, we can see that is initial phase T. T is our data set, okay? The transaction data set. Transaction, the initial pass of T. That means we have to scan the data set, that is the T. And using the initial pass, we have to form the C1. There is candidate C, candidates of one item set. The candidates of one item set, and then from this C1, we can also count, that is the frequency. Okay, count the frequency. Now we have to form what? We have to form the F1 according to our threshold. So here threshold, if we consider threshold is there is minimum support. So on that case, from the C1, some of the item set, that is the frequent item set, we will select that we have to assign to F1. Okay. So where F is an element of C1, that means we can say this is our C1. This F will be the element of C1 if it holds this condition. So it's frequency count divided by n. Here n is the number of transactions. What is it? This is actually the support. Okay, this is the support. The support greater than or equal minimum support. If this condition holds, then we can say F1 will assign the F. Okay. So F, where F is a subset, okay, subset of C1. Now, to find out the F2, so this is the loop for that. From k equal to k is our the frequent item set, and we can see increase by 1, and while f k minus 1 not equal null, we have to just perform this loop. Okay, so this is the loop, and end of the loop is here. And we can see here the candidate generation. So candidate generation, this is another method, another function. So we will also discuss the candidate generation function. Okay, so candidate generation function, it will just take the f k minus 1 as the input. So this is the input. Okay, this is the input. It will consider f k minus 1 as the input. So f k minus 1, that means previous item set. Okay, previous item set, and generate the candidates of k item set. Now we have generated the there is the candidate item set. For each transaction T in our data set, and for each candidate C in our CK, if C is contained in T, then we have to count this C count. That means we have to go back to the data set again and again scan that and find that is the whether C is in that in the data set or not. So if C is there, then we have to increase the count. So this for loop and this for loop, this two nested for loop is for finding out the C in your data set. That is the finding out the frequency of C in our data set. So that is C count. And now after that, what we have to do here is the fk. That means our, if we can say k equal 2, then it will be k2. And in this k2, there is the C, the candidate set, whatever we generate, we if the count, there is C count by n. This is again C count by n. This is again our support count. Okay. So support, if the support is greater than the mean support, then it will add it to our item set of k items. In this way, we have to increase the value of k. Now maybe we want to find out the 3 item sets and then 4 item sets, like this way until the fk minus 1 equal null. Okay. So after that, that what we have to do, we have to return the f by, here is this is the union. Okay. That is, we have to return the f. This is the frequent, in our frequent item set we have to add the item sets of one item sets of two items, like this way. Okay. So in this k equal to 2, so that means we can say union of k. So we have to add all the item sets. Okay, all the item sets. So here's the return. Here's the union of k and f of that is frequent, the frequent item set of k. So in frequent item set of k, we have just assign all the items there. So this is how we will get the frequent item set. But here is one method we didn't discuss it, that is called our candidate generation. Okay? This is candidate generation. So candidate generation. You can see the candidate generation function. So a priori candidate generation, it has actually two steps. Okay, one is called join step and another one is the prune step. So we have already found the join step and we have to apply also the prune step there. So candidate generation function takes fk minus 1 and returns the superset called the candidates of the set of all frequent k items. So that means it will try to find it. That is candidate generation. It will try to generate the superset. Okay, superset. So that means combining, and that is called joining. Okay, joining subsets to prepare the superset. And then we have to also prune. Here is another step is pruning. Okay, but we didn't we didn't actually consider the pruning. We can see that is how pruning will work. So candidate generation fk minus 1, the input will be the frequent item set of k minus 1. And then here is the candidate of k item set. It will be at first null, empty. And then for all f1 and f2 in our fk minus 1. So from this frequent item set, we have to take two elements. Okay, there is f1 and f2. So a small f1 and f2. With f1 is this, these are the items of f1, and f2, these are the items of f2, and we can see that this subset is common. Okay, actually up to this part is common. up to this part is common. So only difference is here. This is I k minus 1 and this one is I prime k minus 1. That means here is a difference. And if we can see that I k minus 1, this one, is less than the I prime k minus 1. So that means here this one or these two, if we can find out that I k minus 1 less than the I k minus 1, the I prime of k minus 1, then we have to combine these two sets. These two set to prepare the superset. So here is the superset. I1 to ik minus 1, and so that means we have to add these two. We get I1 to ik minus 2, then we have to add the ik minus 1 and I prime k minus 1. So these two. That means we can prepare the superset. And this superset, this one we have to add it to our, that is the k item set, the candidate set, okay? Candidate set ck. So we can say that initially it has just null, and then C, if we add C, then it is added. And in next iteration, that is, it will be add new subset, okay? New subset. So in this way, we can generate the C of k. But now for efficiency, we have to prune something, okay? So prune something. The pruning here is for each k minus 1 subset, for each k minus 1 subset of S of C, if S is not an element of F, k minus 1, then we have to delete the C from the CK. It means that for each k minus 1 subset S of C, so we can see that we have already added the C, okay? Added the C. Now consider that in this C, we have to think about the subset of k minus 1. The subset of k minus 1, subset of k minus 1. See, this one is k, okay? That is k. But we have to think about subset of k minus 1. So maybe we will get few subset of k minus 1, k minus 1 and k minus 1. If we see that there is this k minus 1 subset is not in our f k minus 1, not in f minus 1, then we have to delete this C, okay? We have to delete this C. That means this kind of candidate subset actually will not fulfill the a priori properties, and that's why you have to delete those, okay? Delete those. So, and it will also reduce the number of rules, okay? Number of rules, and that's why we have to delete. This is called pruning step. This is called pruning step. And after pruning, after fulfilling all the conditions, we will get the CK.
Sir, could you give an example of what kind of combinations could get pruned?
Yeah. So here is an example for that. Okay. Like in F3, we got this. So what can we do? We want to, at first we want to join and find out the C4. Okay. Now we can see for joining, we have to think about like this, all these are 3 item sets. So we have to think about like the first 2 items must be the same, okay, for joining. So here in this set 1, 2, and here is also 1, 2. Okay, 1, 2. That means we can join this subset and this subset. Okay, so this is our F1 and this is our F2. According to the algorithm, this is our F1 and this is our F2. Okay, so we can join because the last element here is a 3 and here is a 4. Okay, so that means F1, the last element ik is less than I prime of k. So that means we can join these two. So here, after joining, we will get 1, 2, 3, and 4. Here is the 1, 2, 3, and 4. Now we can see here is the 1, 3. Here is also 1, 3. So we can see that here is the 4 and here is 5. So we can join. So here 1, 3, 4, 5. Okay, join. Now here's the 2, 3. You can see none of the set is started with the 2, 3. So actually it cannot be participated in joining operations. Okay, so that means after joining, we will get these two candidates. So candidates set of 4 items. Okay, 4 items. Now we have to try to pruning. Okay, we have to try to apply pruning. And for pruning, at first check this one whether we need to prune it or not. So we can see that from here we can prepare several subset of 3 item set. Several subset, and one subset can be like 1, 2, 3. Several subset of 3 item set. 1, 2, and 3. There is another can be like 1, 3, and 4. 1, 3, and 4. 1, 3, and 4. Another can be like 2, 3, and 4. So 2, 3, and 4. So these are the possible subset we can prepare from here, from this one. Okay, up k minus 1. Now we have to check that whether all of these subsets belongs to our f3 minus f3 or not. There is fk minus 1. So we can say 1 to 3. Here is 1 to 3. Yeah, this is the subset is here. Then 1 3 4. Here is 1 3 4. Yeah, the subset is there. And then 2 3 4. Here is the 2 3 4. That means the subset is there. So that means we should not prune this. So we have to keep this subset. This is a valid subset. Okay. Now again, we have to think about this one. In
Sorry,
this case, we can see that we can prepare the
sorry,
subset. Bolo.
স্যার এখানে 1 to 4 হয় না?
Okay, 1 to 4 হবে না কেন?
মানে স্যার
1 to
তিনটা
4
যে
লিখিনি না?
সাবসেট, হ্যাঁ, হ্যাঁ, জি
1
স্যার,
to
1
3
to 4।
লিখছি, তারপর 1 3 4 লিখছি। 1 to 4 হবে, হ্যাঁ। 2 3 4 হবে। 1 to 4 হবে, হ্যাঁ। 1 to 4 হবে। 1 to 4, হ্যাঁ। So we can see 1 to 4 is also here. Okay, 1 to 4. Okay, thank you. So now we can see here, if we just make this subset here, that means 1 3 4, 1 3 4, then 1 3 5, 1 3, then 5. Then we can generate another subset like 1 3 4 and 1 3 5, and then 1 4 5, 1 4 5. And also 3 4 5, 3 4 and 5. Okay, so these 4 possible subsets are in this case. Okay, so now we can see 1 3 4. At first check the 1 3 4. Here is 1 3 4. That means 1 3 4 is there. 1 3 5, 1 3 5 is also there. 1 3 5. Then 1 4 5. No, 1 4 5 is not there. So that means this subset is not present in F3. So then we can prune it. That is, it is a candidate of pruning. So we can prune it. So we should exclude this one from our, that is, candidate subset. Is it clear now?
ইয়েস স্যার।
Okay. Okay. So this is how we have to apply the candidate generation function. Okay, I think we understand this. Okay, so now I think it's better if we can see it just in a single slide about our item set generation. So at first we have to consider our data set. So this is the data set we have and items we have. Then we have to scan the data, this data set. So that means this is our data set, and we have to create the C1. So C1, that is candidate set of one items. One items we can see we have 1, 2, 3, 4, and 5. So 1, 2, 3, 4, and 5. And then we have to count the support, that is the frequency, count the frequency of 1, that is support count. So here is support count is 2, 3, 3, 1, and 4, 1 and 3. And then it's better if we can write also here, that is the support, okay? The support. From the support count, we can easily find out the support value. So now here the support count from we can find out the support. So that means 2 by count is 2 out of the 4, okay? N is 4 in this case. The support will be like 0.5. Okay, so here we have to mention that this is 0.5. So in this way we can actually write down the support. Now what we have to do, we have to prepare our, there is F1 or L1. F1 is frequent item set, or you can say frequent list. So here is the L1 is the list one. That is frequent list of frequent item set 1. So for if we want to find out that, then we have to apply this filter, that means minimum support filter. So if here we have considered that mean support is 0.5. So based on that mean support, we found that 1, 2, 3, and 5, those are the one item set, and their corresponding support value is given. Now next what we have to do, we have to apply the join operation. Okay, apply the join operation. But we can see here that is in this case just one item is there. So the previously it is just null. Okay, so 1 and 2 can combine, and then 1 and 3 can combine, and 1 and 5 can combine. Okay, so we can join, and then 2 and 3, and 2 and 5, and 3 and 5. So we can combine those. So that means this is our candidate set. And again, we have to count the candidate set. To count that, you have to again scan our data set D and count that is 1 and 2, how many times 1 and 2 appeared. 1 and 3 appeared like this way. Okay, so these are the, and corresponding support, we have to write also the corresponding support value, not only this frequency. Okay, support value. And then according to this, what we have to do, we have to form the, that is F2 or L2, that is the frequent item set of 2 items, or list of frequent item set of 2 items. Okay, then we have to filter out using our min support, and we can see that these are the possible values. Okay, these are the possible values. And now again we have to apply our candidate generation. So for the candidate generation, what we have to do, we have to find out like here 1. So that means to combine the 2 items, we have to the subset, that is the k minus 1, it must be matched. Okay, so here is 1, but none of the item has initiated with 1. So that means actually we cannot combine anything with this subset. So here is the 2 and here is the 2. That means we can combine these 2 and to form this 2, 3, 5. Okay, 2, 3, 5. And here is the 3, but we can see none of the item set actually started with 3. So it will actually not participate in any join operation. And then this is the item set. Okay, this is the item set, this is candidate item set, but we can apply whether we can prune it or not. Okay, that means we can prune something or not. So for pruning, what can we do? We can think about like 2 item set. So here the possible 2 item sets are 2, 3, and then 2, 5, and then 3, 5. Okay, 3 5. So now we have to check whether these are uh, in our there is L2 or not, or F2 or not. Okay, so 2 3, 2 3 is there. Okay, this is here, and 2 5, 2 5 is here, and then 3 5, 3 5 is here. Okay, that means all the subsets are belongs to our L2. It means we should not pronate. So we should continue with this. Then again, we have to scan the data set and find out the frequency and also the support. Okay, support count and support. Okay, and based on that, we have to again check our there is the mean support, and we can see mean support. It passed the mean support threshold. Uh, then this will be our final item set of three items, and this a priori algorithm will return the item sets. Okay, there is the item set of 3 items is 2 3 5. The item set of 2 items is 1 3 2 3 2 5 and 3 5. So those it will return those.
Sir, as we are trying to use this in autocomplete, so suppose I have pressed one character, it will give me the in the suggestion box. It will give me the item set of one item like L1. And if I have pressed two characters, then it will give me the item set of L2 in my suggestion box. Is this how it works?
Yeah, it can be. It can be. That means that it can be like suggested like that way, or we can say from the one it can also predict something. Some advanced methods you can apply there and predict something. Okay, you are maybe you press just two, so maybe it's that is you want just 2 3 5. Not only the 2 3. It can show you like 2 3 5.
Buchi.
You understand? Okay.
Yes, sir.
Okay, now the a priori algorithm. So we have already generated the item sets, and we know how to generate that, specifically the a priori algorithm and candidate generation algorithm. Okay, using those two. Now from our item set, we have to generate the rules. So how can we generate the rules from the frequent item set? Actually, frequent item set are not the association rules. Okay, so we know we need to do one more step for that. And for each frequent item set X, for each frequent item set X, so for each proper non-empty subset A of X, let B is X minus of A. So that means for each frequent item set, that means you need to consider frequent item set of one item, 2 items, 3 items. Okay, so all. So in this case, if we consider, okay, maybe we have the 3 item set as we got already. Maybe the last one is 2 3 5. 2 3 5. So 2 3 5. 2 3 and 5. So we got the last one. We also have like the 2 item sets, frequent item set. 1 3 2 3 2 5 3 5. Okay, so all. Actually, we have to consider all frequent item sets. 1 3 2 3 something. 1 3 2 3 2 5. Okay, so let's say this is our X. Then for each proper non-empty subset A, so we can see that from here we can prepare the non-empty subset. Okay, so that means we can prepare like 2. This is a subset. We can consider this one as A. If we consider this one as A, this is our subset A. Then in B, in B, what we have to consider? We have to consider x minus of, this is our x. So this is our x. So x minus of, that means 2, 3, 5 minus of A. A is 2. Then what we will get in B? We will get 3, 5. This is set difference, okay? I think we know this. So here is the A and B. So in this case, now we can say the A implies B. This is an association rule if confidence of A and B greater than or equal minimum confidence threshold. So that means from here we can generate a rule that is 2 implies A implies B, that is 3 and 3, 5. Two implies 3, 5. So this is association rule, but we will call it a valid association rule if the confidence of this is greater than the minimum confidence. Okay, so that means we have to find out the confidence of that, and we know how to calculate the confidence. Okay, how to calculate the confidence, and for that, maybe you can, if we can see, if we want to find out the confidence of this, then at first we have to find out the support of A and B. Okay, so that means A union of B divided by the support of left hand side. Left hand side is in our case A. Okay, so in this case you can see support of A union of B, support of 235. So support of 235 is what? From our data set we can see 235. Here is the 235 and here is also the 235. So support of 235, it will be 235 2 times out of 4. So support is 0.5 divided by, so it is, we can see the support, it is 0.5 divided by the support of A. The support of A is what? A is 2 here, okay? A is 2. So in this case, we can see how many times 2 appeared. We can see 3 times, okay? 3 times 2 appeared. So support of A is 3 out of 4. So it is 0.75, 0.75, 0.75. So here is 0.75. So then our confidence will be, the confidence will be actually, it is 0.5 is 2 by 4 here. This one is 3 by 4.
Sir,
So it is
0.67.
0.67. Okay, 67. Okay, 0.67. So if we consider the minimum confidence, like maybe 0.6 or something, okay, minimum confidence, the threshold, confidence threshold is 0.6, then it will pass that threshold, okay, 0.67. This will pass the threshold. That means on that case, we can say that this rule is selected as our association rule. Okay, so this rule. So similarly, we can generate several. That is our subset from this X. Like we can consider A equal 3. We can consider A equal 5. We can consider A equal 2, 3. We can consider A equal 2, 5. We can consider A equal 3, 5, okay, and corresponding B we can determine by subtracting the A from X. So this is from 3 item set, okay. Similarly, we have to think about our 2 item set like 1, 3. In our 2 item set we have 1, 3. So what we can do, we can select the a equal like 1. On that case, B will be just x minus a. It is just 3. B will be 3. And then the rule, it will be 1 implies 3. So this will be the rule. And we have to test again whether this rule actually holds the minimum confidence threshold or not. Okay, if this one just pass the minimum confidence threshold, then this can be another rule.
So the order doesn't matter when we are coming up with A.
No, no, the order doesn't matter in this case.
So can it be 5 comma 3? The same thing.
Yeah, 5 comma, yeah,
Okay.
this one, yeah,
Yeah.
it can be 5, 5, then 3, it can be. But it will be the same, okay? Because you can say 3, 5 and 5, 3, it will be the same. Because these are the 2 items, it is set. So in any set, the order doesn't matter in that case, inside the set. Okay, so next is, okay. So rule generation, so we have already discussed about this. So if we consider F, so here is one thing that is example like for L, ABC, we can consider like A, so AB, then C, then AC, then B, and then BC, A, and also we can consider A, BC, BAC, and CAB. Okay. So the calculation is if we have 3 items, then the possible rules could be like 2 to the power k minus 2. So it will be 2 to the power 3 minus 2. So that means 8 minus 2 is 6. In this case, we have from the 3 items, we can generate maximum 6 subsets, okay, 6 rules. And you have to test all actually. So suppose this is our frequent which support this one frequent item set. So proper non-empty subsets, it could be like 2, 3, 2, 5, then 3, 5, then 2, 3, and 5. Okay, so these are the possible proper non-empty subset. And their support is the 50%, 75%, 50%, and then corresponding, we can say confidence, we can easily calculate the confidence, 100%, 67, 67 like this. Okay. All rules support greater than 50. So if we can set a threshold like uh, you need to find out the rules with support 50% and the confidence, there is the minimum confidence of 80%. Then on that case we will get just only 2 rules, this one and that one. Okay, these two rules will be our output of association rules. Is it okay? Any confusion? Do you have any confusion or any question? কোনো 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 কনফিউশন আছে কি তোমাদের?
No, sir.
No,
No,
sir.
sir.
One last thing we have to discuss. So we already know about the support and confidence, okay? Support and confidence. But the support and confidence have some sort of limitation also, okay? So I think it's better if we can go. So I think you will know these things, but one thing in practice, the K is bound to 10. Actually, um, we can say that that is K. K is the size of the item set, okay? So it can be like 100 item set, it can be 1000 item set, but it is better to keep the K equal 10. Okay, that's why it is a recommended, okay? But that's not the hard and fast rule, but it's better if we can keep it within 10. So this is the actually complexity for that, order of 2 to the power m. Okay, so this is also one of the information for association domain. Okay, so the criticism to support and confidence. So let's say we have a set like we have elements like we can see the x, y, and g. So x, y, and g. We have 3 elements, and this is the transaction 1. That is a small t, okay, a small t1. This is our small t2. This is our small t3, like this. Okay. Then we can see that there is the 2 items. One item is x, another item is y. Okay, item is y. Then we can see that actually here is 1, here is 1, here is 1, and here is also 1. And for here is 1, but it is 0. Okay, it is 0. So here is 1, but it is 0. Here 0, here is also 0. Okay, this is 0, here is also 0. 0, here is also 0. 0, here is also 0. Okay, now these two, if we can see that most of the time, like when 1, here is 1, here 1, here is 1, and we can see 0 and 0. So this part and this part. Okay, so that's why it is called, is if we think about correlation, then these two are positively correlated, x and y, positively correlated. And if we think about like the g here, there is x with g, x with g, then we can see that when here is the 1, it is 0. And also we can see when it is 0, it is 1. And all the cases we can see 0, here is 1. So this is negatively correlated. Okay, negatively correlated. Some form of inverse correlation between them. But in case of the support and confidence, we can see that if we determine the support and confidence for x, y, and xg, so if we that is count the support between x and y, here you will get the support 25%, support 25%, and confidence 50%. And for x and g, the support you will get the support like 37.5%, and here the confidence will be the 75%. Though we can see this one has the positive correlation and this one has the inverse correlation, but we can see that still the support and confidence is high for the inverse correlation. So this is problematic. Okay, this is problematic. And that's why the support and confidence, sometimes we also mention that this is not enough to find out the strong rules, okay, strong association rules. And for that, some advanced metrics usually we use, and one of the advanced metrics usually we call it lift. So lift measures, we can see that lift between x and y, or x implies y. It will be the support of x and y, so support on x and y divided by support on x times the support of y. So additional thing is this. You can see in our confidence relation, confidence actual equation, support of x and y divided by support of x. But this time support of x and y, we have to divide it by x and also y. So now here for this data set, if we want to find out the lift, okay, then then for this case, like for example, one rule is there: milk, bread, and butter. Okay, so this is the rule, one of the rule considered, and we want to find out the lift of this equation, of this rule. The lift will be so at first the milk, bread, and butter. Okay, so that means the support of x and y. So this side is, the left side is x and right side is y. We have, so milk, bread, there is milk, bread is x and butter is y. So in this case we can see milk, bread, and butter, three combinations: milk, bread, and butter. So we can see here, this is the case: milk, bread, and butter. So that means the support will be, the support in this case, you can say the support here is out of 5, just 1 by 5. Support is 1 by 5. That means support is what? 1 by 5 is 0 0.2. Okay, so 0 0.2. So here is the 0 0.2. And then support of x. Support of x means what? Milk and bread. So we can see milk and bread 1 time and 2 times. Okay, 2 times milk and bread together. So out of 2 times out of the 5, 2 by 5. So 2 by 5 is what? 2 by 5 is 0 0.4. So here is 0 0.4. So just a minute, please. I have a call from outside. So okay, in this way we can calculate the lift. Okay, lift. So in this case, you can see that actually, if we can get there is the our lift one, lift equal one, then x and y those are independent. Okay, the x and y will be independent. And based on our lift, we can also define something else, something more like one of the observations we can say that there is x and y are independent. That means they have no correlation, or you can say we cannot make like association between x and y if we get the lift just one. But what else we can also mention from our lift calculation. So if lift is greater than one, then actually it tells us the degree of which those two occurrences are dependent on one another. So it means that uh, those rules are potentially efficient. Okay, efficient rules. So if we get something like the greater than one, and another thing is also we can derive like if lift is less than one. So we can say that those items are substitute items. So that means one item can replace another item, or we can say we should not put those items together because it has negative impact. Okay, negative effect or negative impact. So that means lift, it will tell us not only just only the association. So uh, the perfect association for lift is greater than one. The value is greater than one. But when we will get there is less than one relationship, that is those are the substitute items, and we should not put those items together. And also it will tell us that is if it is one, then the x and y those items are independent. Okay. Uh, so that's why not only the support and confidence, we have to calculate the lift of AR. Another actually metric also we have. Usually we call it convict. This is the conviction. The conviction, it is defined is like 1 minus support of y divided by 1 minus that is confidence of x uh, implies y. So if we can, if I think we know how to calculate the support, how to calculate the confidence. Okay. So if we define this the support and confidence, and if we want to find out the conviction of this rule, then you will get this 1.2. Okay, 1.2. So this conviction 1.2, it means that yeah, it would be incorrect 20% more often if x and y was just purely random chances. So it will determine the conviction. That means if those just x and y items are we can select just randomly. That means they have no correlation, or you can say uh, uh, the the users also purchase those items just without without any association between them. Then uh, there is the 20% more often if the association between these two are purely random. That is if we select those items just in random manner, random way. So that's the conviction will tell us. So that's why it is mentioned that there is the conviction can be interpreted as the ratio of expected frequency that occurs without y. What does it mean? It means that the frequency that the rule makes an incorrect prediction. Okay, incorrect prediction in random selection. So that means if those items are just selected randomly without following any association, then it will it will occur 20% more error for that case if we have like 1.2 conviction 1.2. Okay, so this is another measurement of our association rules. So these are all in our association rule
So,
lecture.
the best case is having an association, sorry, a conviction of one. then there is 0% chance of.
Yeah, the best case is if we get the 1, or even less than 1 is fine. Okay.
Sir, it can be less than one.
It can be less than 1.
Okay, sir.
Okay, thanks all of you for joining this session. See you in our next class.
Sir, if it's less than one, what does that mean? Like, for example, if it's 80%, does that mean that it's 20% more accurate?
Yeah,
What does
if
that?
it's random, okay, then 20% error. But if it is like maybe that is less than 1, then we can say that maybe it will be 20% accurately, 20% accurate for that case.
Oh, acha, বুঝছি. So if it's one, then it implies that it is completely random. If it
Yeah,
is greater than one, it implies that there is a percentage of error that's gonna happen. And if
yeah,
it is
20.
less than one,
No, yeah,
then the percentage of times it's gonna be correct.
yeah.
Okay, interesting.
Okay, thank you very much. So see you in the
Assalamualaikum,
next
sir.
class. Walaikum
Allah
Assalam.
Hafiz, sir.
Allah Hafiz.